Hello guys, my name is Ankit Tiwari. Hope you have enjoyed my previous videos. Today I am going to post my new video on class 9 physics topic, statement and derivation of Newton's second law of motion. But before going into that topic, I want to state some of the basics related to that topic. So guys, what is momentum? Momentum. Momentum is defined as the quantity of motion of a moving object measured as product of mass and velocity. So friends, in simple words, momentum is defined as the tendency of a moving object to continue moving. In simple words, it can be defined as tendency of a moving object to continue moving. Now, I will let you know the mathematical formula of calculating momentum. So, let P be the momentum of object, M be the mass of object, and V be the velocity of object. So as I have stated that it is the product of mass and velocity. So momentum is equal to mass into velocity. By inputting all these symbols in this formula, we will get momentum is P, mass is M, and velocity is V. So P is equal to mv. This is the mathematical formula of calculating momentum of an object. That is, momentum is equal to mass into velocity. After explaining the concept of momentum, I will switch on to my topic, that is statement and derivation of Newton's second law of motion. First of all, I will let you know the statement of Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force in the direction of force. So this law states that the rate of change of momentum is directly proportional to the applied force in the direction of force. In order to make this statement more clear and understandable, I will switch on to its derivation. For derivation, let us consider that an object of mass m kg is moving with an initial velocity per second. So there is an object whose mass is m kg and it is moving with an initial velocity of u meter per second. Then an external force F is applied on that object for a unit time t. So an external force is applied on this object for time t. Okay? Before proceeding, I will draw the diagram again because it will be used in the derivation. M kg u meter per second, and this is the force. So I stated you that there is an object moving with an initial velocity u and an external force F is acting on this object for time t. Now, due to application of external force, there is change in momentum of the object. There is change in momentum of the object. Now friends, you must be thinking that why there is a change in momentum of this object due to the application of this external force. That because when this force is applied on this object, then the velocity of this object, which was earlier u, will get changed into v, which is the final velocity of the object. Change in momentum occurs because on application of external force, the velocity of the object changes from u to v. This was initial velocity, and after the application of F force, its velocity got changed to v, which is the final velocity. It's very simple, guys. If an object is moving initially with a certain velocity and after some time an external force is applied on that object for time t, then definitely its speed will get changed from its initial velocity to a certain velocity. So here that velocity has been changed from u to v. U was initial velocity of the object with which the object was moving, and after application of force it get changed to the final velocity v. Now, after knowing the cause of change in momentum, we will switch on to the mathematical derivation of Newton's second law of motion. First of all, I will signify all the notations related to it. M, mass of object. U, initial velocity of object. V, final velocity of object. T, time taken. F, external force. A. Acceleration of object. So all these symbols will be used in the mathematical derivation of Newton's second law of motion. Now, according to Newton's second law of motion, it was stated that external force is directly proportional to rate of change of momentum. Rate of change of momentum. So it can be written as external force is directly proportional to change of momentum upon time taken. Rate of change of momentum can be written as change of momentum upon time taken, because rate of change of momentum is change of momentum per unit time. That's why I have written it as change of momentum upon time taken. Next step will be external force is directly proportional to change of anything in physics is final minus initial. So here change of momentum can be written as final momentum minus initial momentum. Final momentum minus initial momentum upon time taken. Next step will be external force will be directly proportional to final momentum can be stated as mass into final velocity, and initial momentum can be stated as mass into initial velocity, because at the starting of the video I have stated you the concept of momentum, and where the mathematical formula for calculating momentum was mass into velocity. So here it is final momentum, the velocity considered in the final momentum will be the final velocity, and the velocity considered in the initial momentum will be the initial velocity. Now, by using all these symbols, we will insert those values in this line. Thus, the next step will be external force is F. So, F will be directly proportional to mass is m, final velocity is v, mass is m, initial velocity is u, and time taken is t. So, F is directly proportional to m v minus u upon t, because m is common in mv and m. So F is directly proportional to m v minus u upon t. Now, our last step was F is directly proportional to m into v minus u upon t. Now friends, in my first video, which was on equations of motion, I stated you the first equation of motion, which was v is equal to u plus at. V is equal to u plus at. First equation of motion. From here, v minus u will be is equal to at, because I have shifted u from right hand side to left hand side, and v minus u upon t will be is equal to a, because I have shifted t from right hand side to left hand side. So v minus u upon t can be termed as acceleration, which you all know in the first chapter of physics of class 9, that is motion. So acceleration is v minus u upon t, or acceleration can be defined as rate of change of velocity. Acceleration can be defined as rate of change of velocity. So friends, this step will not be included in this derivation. I have just explained you so that you can get it clearly. While I will insert A in place of V minus U upon T. That's why I have explained this from the first chapter of physics, that is motion. So there is no use of this part in this derivation. So I will rub it off. Now, F is directly proportional to m into A because acceleration is V minus U upon T. Now, when we change the proportionality sign to equality sign, then a constant is introduced. So, when we change this proportionality to equality, then a constant K will be introduced. K is the constant of proportionality. Proportionality. In SI system, K is taken as 1. By inserting the value of K equal to 1 in this equation, we will get F is equal to ma. So friends, by the mathematical derivation of Newton's second law of motion, we have derived the formula for calculating force, which is force is equal to mass into acceleration. Thus, force is equal to mass into acceleration. By this formula, we can easily calculate force. So friends, with this, I have stated the Newton's second law of motion and also derived the mathematical formula for calculating force, that is force is equal to mass into acceleration based on Newton's second law of motion. Hope you must have liked this video of mine, and please like, share and comment on my videos. See you soon with some interesting topics of class 9th and 10th physics and maths. Thank you.